Hello people. So in this video we are going to take a look at WebGPU. So WebGPU is this interesting API which has just become stable. So it was under development for a long time, but I think it is now stable in multiple browsers including Chrome and Firefox. So this is so for people who don't know what WebGPU or any kind of GPU API is, it's basically a set of tools or set of APIs which allows you to utilize your GPU to do stuff with it. So in most cases you want to draw something onto the screen using GPU, but people use it for a lot of different things, for AI example. So WebGPU is basically a successor API to WebGL, this thing. So this is also a graphics API, but this is very old and there has not been much progress in this thing. So it came at around 2011 and last stable release was 9 years ago. So for 9 years there has been no movement in this thing. So we are going to take a look at WebGPU. So in fact this is my first time taking a look at a WebGPU. So we are going to explore this API from the start together. So let's just create a project for this thing. I like to so we are going to utilize TypeScript, so it would be better to create a webpack project. So let's use node 20 and create new webpack app. Oh yeah, forgot to give name. Let's say WebGPU. We will be using TypeScript. We don't want that. We don't want that. CSS only for now. Nope, only for and npm. Yeah. So let's see if we can find some documentation for this thing. Yeah, let's go with a minimal example. And before that also npm WebGPU types. Yeah, WebGPU types. Let's also install this thing. It has created the project. Let's see if we can find anything. Okay, we initialize some GPU. Okay, this looks like a good starting point. Yeah, let's just go with this thing. Does it have, there is some renders, pass descriptor, pass encoder. Okay, let's just see what we can do. Okay. Let's see. Navigator.gpu. Interesting. So you get the GPU on Navigator itself as opposed to getting a context from canvas. So let's create a canvas first. We don't want that. Okay, let's create canvas with canvas ID. I wonder if we are going to even need this. We don't have navigator.gpu. I think we have to change tsconfig 2015. Does not exist on navigator. We have WebGPU types, but not this thing. Does this thing help? Not really. How can we get this thing working? Okay, we install this thing. Yeah, we have to do this types thing. Yeah, now we have it. Let's just see what kind of thing we get inside of the GPU. We have to run our project, of course. Let's run it like this. And let's start a HTTP server. Okay. Okay, we have GPU, and we don't have much things in here. Okay. Let's see what do we do further. We try to get adapter asynchronously. Okay, let's just create an immediately invoke function, async, and await navigator dot gpu dot request adapter. Let's just try to log the adapter. Okay, we have the adapter. Nice. So there is info about the adapter. Swift shader, backend Vulkan. Nice. So this is using Vulkan as a backend. Swift shader, device sub-zero. We have device ID, it seems like, driver, and a bunch of stuff. So memory, if it looks like it also gives us access to the heap memory of the GPU. But I wonder how much things we can do with this thing. Okay, cool. Let's go further. Request device. So we have concept of adapter and a device. So let's just see briefly what adapter is. No, not this kind of thing. In WebGPU, specific physical software based graphics processing unit available on the user system. It acts as an abstraction layer obtained via request adapter, allowing web applications to query hardware capabilities. Okay, it seems like it is very similar to the thing that we saw earlier. This thing, basically what kind of features we have available in the GPU. Okay, so next thing we do is we take a device from the adapter, request device. Okay, device is equal to adapter dot request device. And is this thing async? Yeah, it returns a promise. So let's await on this thing, and let's see what we get in the device. Okay, so we got a GPU device. We have adapter info just like we had previously. We have features, we have limits. Okay, interesting. So this is like the how many things we can upload to GPU basically. Okay, lost. I don't know what this thing is, and we have queue. Okay, features, supported features. Okay, I don't think it's going to be any interesting to us. So we get canvas and we get WebGPU. Okay, we do it in a similar way to how we do it with 2D context or WebGL context. So preferred canvas format, and we configure the context, we provide device, and we provide preferred format, and these kind of things. Okay, let's just get a canvas and get context is not there on. Okay, we have to cast it as HTML canvas element. Okay, do we have WebGPU now? Let's see. Yeah, we do have WebGPU. And what are they calling this thing? Just context, let's say CTX for simplicity. Okay, so next they get a preferred canvas format. So let's see what that thing is. Format, they are taking it from navigator GPU. Navigator get preferred canvas format, and let's try to log this thing and see what it is. Device, no, not device, but format. RGB. Okay, it's just image format. Okay, let's continue. So we configure the context, we provided device. So device I suppose means the actual GPU. Format is the image format, and we have alpha mode. Okay, so context.configure, we provide device, we provide format, and the last thing was alpha mode, opaque. Okay, so let's continue. Clear color is red. Okay, let's just have a clear color, just R1. E is going to be 0. Okay, what do they do next? Command encoder, create command encoder and render pass. Command encoder. Okay, let's see. Device, create command encoder. Let's see if we have any information on this thing. Creates a GPU command encoder, so they don't link it to any documentation or anything. Descriptor. Okay, let's just try to log this thing and see what kind of things we have in here. Right, it is doesn't seem like it has many things. Just label, empty label. Okay, I don't know what that thing is. So let's quickly Google it. What is an object used to record a sequence of GPU commands? Okay, command encoder. Interesting. We have to explicitly create this thing as opposed to other APIs like WebGPU. They do this thing internally. Okay, so let's just continue. After command encoder, we create a render pass descriptor. So it seems like render pass descriptor is used to generate one frame. Basically, that is what it is used for, I guess. So we have color attachment. We pass color attachment and its array. So we have view, get current texture and create view. We have clear color, load OP, clear the attachment at the start of render pass, and then we have store OP. I guess these are load and store operations. Pass encoder. We have command encoder and pass encoder. Begin render pass, and we end this, and we submit the command encoder.finish. Interesting. Let's just first create render pass descriptor. It's just an object. I wonder it has types. So we pass it to render pass descriptor. So let's try to determine type of this thing. Pass encoder. Basically I'm trying to get the type of this thing, this function, whatever this function is expecting. So command encoder dot begin compute pass. Okay, yeah, so this thing has compute pass separately as opposed to render pass. So I am assuming compute pass is going to be used for compute shader, and render pass is basically for doing rendering stuff. So if you want to do AI and stuff, matrix multiplication, those kind of things, you would use compute pass. But for now let's just use render pass, and it accepts a GPU render pass descriptor, this thing. So this thing is going to be type of this thing. Yeah, now it is suggesting we use color attachment. So this is going to be array. Yeah, and again this will expect things. It can be null also, null undefined, and color attachment. So it wants it at least wants these things. It wants view. So view is going to be this thing. Let's try to understand, and I'm going to comment this thing for now. It wants this thing, color value. So they were also using color value. Yeah, this thing and this thing, GPU color. Let's just see one by one what kind of things we can do here. This is optional thing. So clear value, they were providing this thing, and view was GPU texture, and that thing load OP and store OP. So this indicates the load operation to perform on render pass color attachment. So it seems like they have some attachment system, so similar to how in WebGL you would bind vertex arrays or textures and all these kind of things. I think it's just different in terminology. So in WebGL they were using this terminology. Let me just compare it side by side. WebGL samples, WebGL example. Let's see in JS. Okay. Let's see if we can find a minimal example for this thing. Yeah, so here it is. So this is too minimal. So smallest programs, let's see if we can find something here. Clear color, enable. Yeah, we have enabling system here. We do this kind of things. We have some shader programs. Okay, anyways, let's not go too deep into that thing. Indicates the load operations. So there are load and clear operations, and in store we have store and discard operations. Okay, let's just provide this thing. Okay, for load operation we can have load and store, and let's just verify if they are doing the same thing. Now we have clear operation and store operation. I suppose this is to clear the canvas with this clear color. Okay, that makes sense why we have clear value as operation. Render pass color attachment. Okay, this is some new territory here. Let's just try to get something on the screen first. Where we, so we get from context, get current texture and create. We are creating view from current texture here. ctx dot get current texture and create view from the current texture. It is interesting how little things we have. So we can configure, we can get configuration, we can get current texture, and we can unconfigure. So brand, workaround for nominal typing. Okay, so we can pass this render pass descriptor to this thing, and so in device queue we submit this thing in queue. Device.queue.submit. Let's see, command buffers, iterable GPU command buffer. What are we passing here? Command encoder dot finish. So command encoder completes recording of the command sequence and return corresponding command buffer descriptor. Command encoder. We also end the pass encoder. And what does that thing do? Completes recording of the render pass commands sequence. It records this thing. And what else do? We just call this thing. Let's see if we okay, we have a red canvas. Cool. Let's clean this thing a bit. Let's put this on top. Let's clear this and make canvas a little bigger. Nine by 80. So we get a nice 720p resolution. Okay, so we got that. I guess this is very naive example, but it's good for introduction. So in next video maybe we'll try to load up some shaders and try to do some things with shader. So this is too minimal, but it sets up the ground for important concepts like adapter, device format. Then we configure things. There is concept of command encoder. In next video we'll see if we can have more commands, or what can we do with these things. We'll also try to see if we can load some shaders. I'm aware that WebGPU uses a completely different shading language, so we will take a look at those things in next video. That's it for this video.